Hey guys, HackerSploit here, back again with another video, and in this video we're going to be taking a look at how to exploit the Log4j vulnerability. More specifically, we'll be taking a look at how to exploit the vulnerability on Apache Solr. Alright, so in order to demonstrate the actual exploitation and patching process, I'm going to be utilizing a room on TryHackMe that has been set up to actually cover most of the exploitation phase, or really just the entire exploitation phase, as well as detection, mitigation, and patching, right? So it's going to be really cool, and I'll be trying to explain every step as best as I can so that you guys get a better understanding of how of how to perform this particular attack or to exploit this specific vulnerability. Now, I just want to point out that I did have a session yesterday, which was Friday, on INE Live, where I highlighted or demonstrated how to exploit this vulnerability on Apache Tomcat, on an Apache Tomcat instance that has been configured to use Log4j. So that's something that you need to take into consideration, right? All right, so I've already started the target system, and you can see it gives you an introduction here. And of course, this vulnerability or this particular exploit is known as the Log4Shell exploit, and is identifiable under the CVE code 2021-44228. So I just want to make that clear. So on December the 9th, 2021, the world was made aware of a new vulnerability identified as CVE 2021-44228 affecting the Java logging package Log4j. The vulnerability under severity score of 10, the most critical designation, and offers trivial remote code execution on hosts engaging with software that utilizes Log4j version. And this attack has been dubbed Log4Shell. So the Log4j version 2.16.0 has patched this particular issue by disabling the JNDI lookup plugin, which I'll get to in a few minutes. And you can actually take a look at the release notes there by clicking on this GitHub repository link. And again, it gives you a basic description as to how this particular vulnerability works. And if you want to learn more about the actual attack surface for this particular vulnerability or this particular attack, you can click on this GitHub repository here. And as you can see, it'll give you a list of manufacturers, vendors, or applications. So for example, Apache Solr. And it'll then give you a description and evidence that this does indeed work. All right, so you can actually confirm that that is the case. So you can go through each of these, each of these vendors or manufacturers and take a look at, as to whether or not they are vulnerable. And of course, this table here will tell you whether, it's actually true or false. And in this case, you can see Apache Flink. If we click on that here, you can see there's no description or evidence. That doesn't mean that it's not vulnerable. It's just relative to this particular GitHub repository. And of course, if you want to learn more about this vulnerability, you can actually take a look at the following links. And yeah, so we can get started. So I'm just going to deploy the target machine, which I have done. And yeah, I think we're ready to go to the first task, which is Reconnaissance. All right, so the target virtual machine includes software that utilizes the vulnerable Log4j package, offering you a playground to explore the vulnerability. After deploying your virtual machine, you should find that the IP address accessible with the TrackMe VPN is provided to you. To begin, start with basic reconnaissance to understand what ports are open. So we need to perform a port scan here. So I'll just copy the target IP and I'll head over into my terminal, and we can say nmap sv target IP, hit enter, and let's see what service is actually running on the target. All right, the nmap scan is complete, and looks like we didn't get any results pertinent to the port that we have Apache Solr running on. So we can be a bit more specific, and the port in this case is going to be 8983, and I'll hit enter. All right, so the nmap scan is complete, and as you can see, it tells us on 8983 TCP we have Apache Solr running, and we can access it via our web browser. So I'm just going to copy that, and we'll open up a new tab here, and we'll say 8983, like so. And there we are. So it takes us to the Solr admin page. All right, so what is Apache Solr, right? Because many of you may be asking yourself the question. Well, Apache Solr is essentially a scalable search engine that's used to, again, to optimize, search queries or a search index for large amounts of data, right? And is used by companies or by websites that, require or utilize a search engine for a lot of content, right? And part of that functionality involves the use of cores. Now, I wouldn't go into, the functionality of cores in relation to Apache Solr, but I'll actually talk a little bit about it once we get there. For now, if we take a look at the try hack me task here, you can see we can perform the nmap scan, scan the machine to determine what ports are accessible. There we are. What service is running on port 8983, Apache Solr. All right, that's correct. So we can move on to discovery, right? So the target machine is running Apache Solr at 8.11.0. One example of software that is known to include this vulnerability, Log4j package. For the sake of showcasing this vulnerability, the application runs on Java 1.8.0, right? Which means that Apache Solr or the target server has been configured to utilize OpenJDK or Java version 8, all right? So that means that when we'll be creating our Java exploit, we'll actually need to compile that into a class. And of course, it should be compatible with Java 8. So just keep that in mind. And it also consequently means that you will require OpenJDK 8. Alternatively, you can also use the latest version, which is OpenJDK 11, to perform the compilation, but you may experience issues with that. All right, so we need to download a few task files here. And before we do that, it says explore the web interface and click around to get a feel for the application. For more detail on Apache Solr, please refer to the official website. All right, so this instance of Apache Solr is provisioned with no data whatsoever in a flat, vanilla, and absolutely minimum installation, yet at its core, it is still vulnerable to this particular vulnerability. So if we download the task files are essentially provide you with the Solr logs to get an understanding of what information is being logged, right? And that's primarily where this vulnerability comes into play. So I'll just open up the downloads folder, and I'm just going to put this on my desktop under Log4j. There we are. And I'm just going to extract that here. There we go. So Solr logs, we have solr.log. So if we open this up with a text editor, you'll see this will give you a list of all the logs here. And you can actually see the actual path that's being requested, as well as the parameters. So you can see for the path admin cause, we can pass in parameters, and I'll explain why that is, right? Because of the actual path admin cause is an API endpoint that allows you to actually pass in parameters, and all of this input is being logged, so we can potentially utilize that API endpoint to inject the malicious JNDI LDAP payload. So we'll go back into the room here. You can see that it says take a close look at the first page visible when navigating to the actual address. You should be able to see clear indicators that Log4j is in use within the application for logging activity. What is the olr.log directory argument set to? So it's essentially saying where does this particular version of Apache Solr store the log. So if I zoom in a little bit here, let's see whether we can find that particular argument. So you can see dsolr.log.directory. So it stores the logs under var solr logs. So let's copy that there. That should be fairly simple. And submit. All right, download the attached files, which we've already done. One file has a significant number of info entries showing repeated requests to a specific URL endpoint. Which file contains this repeated entry? So yeah, so the actual log file that we can see here has multiple info entries here, and the name of the file is solr.log. So let's try that. There we go. All right, so the path or the URL endpoint is indicated in these repeated entries, and of course we were able to identify that is admin cores. All right, that's correct. Viewing these log entries, what field name indicates some data entry point that you could use, you as a user could control? Just the field name. All right, so what field name indicates some data entry point? So parameters, that is correct. So that's fairly simple. And the proof of concept. All right, so note that the URL endpoint that you have just uncovered needs to be prefaced with the Solr prefix when viewing it from the web interface. This means that you should visit the following address, right? So let's actually open this up in a new tab here. There we go. So you can see this is an API endpoint, which means we can specify parameters here. So for example, I can say cmd equals, and then I can pass in the actual malicious JNDI lookup or JNDI LDAP payload. So I could say, pass it in here, and then within the curly braces, I can, invoke the JNDI lookup plugin and say LDAP, specify the actual address of the LDAP server, so on and so forth, right? But before we get to that, let's understand a bit more about, how Log4j works. So as you can see, it says you also notice that the parameters seem to be included in the log file. At this point, you may already be beginning to see the attack vector. So if we take a look at the log files, you can see that the parameters are again added to the log file, which means that really the crux of this vulnerability revolves around the fact that logs being entered into the Log4j log file will get executed, or specifically some logs will get executed. And if we take a look at the documentation here, you can see it actually highlights that. So the Log4j package adds extra logic to logs by parsing entries, ultimately to enrich the data, but may additionally take actions and then and even evaluate code based off the entry data. So the gist of this vulnerability, that's essentially the gist of the vulnerability. Other syntax may be in fact executed just as it's being entered into log files. Now, with Log4j, you have the ability to perform lookups, and lookups can be performed with the following syntax, where you have the prefix and the name is what is going to get executed, right? And we do know that Log4j actually logs these specific parameters. So it'll tell us right away, you may already know the payload to abuse this Log4j vulnerability. The syntax looks like the following. So this is the malicious JNDI LDAP payload, right? So you can see we invoke the JNDI plugin, and then we say we want to connect to an LDAP server, and then we specify the IP address of that server. All right, so the syntax indicates that Log4j will invoke functionality from JNDI or the Java naming and directory interface. Now let me explain something here that a lot of people don't really understand, right? And that, of course, is JNDI injection. So JNDI essentially provides Java-based applications with an API endpoint that can be used to interact with services like LDAP or any other directory services in order to access external resources. So with Log4j, we can utilize the JNDI lookup plugin in conjunction with LDAP to essentially obtain an external resource that's being stored on whatever server, right? And it's also important to note that Apache Log4j versions 2.0 beta 9 to 2.15.0 all come pre-packaged with the JNDI lookup plugin. So all of those versions really are vulnerable in to a certain extent. Now, an attacker could potentially use the JNDI plugin in conjunction with a malicious LDAP referral server that's being controlled by us to instantiate a malicious Java class. And, an LDAP referral server essentially is used to provide a reference to an alternate location where an LDAP request may be processed. So this will make sense once we actually get started with the actual exploit, right? So you can see that it says, notice the LDAP schema. This indicates that the target will reach out to an endpoint, an attacker control location in the case of this attack, via the LDAP protocol. For the sake of brevity, we'll not cover all of the ins and outs of LDAP here. All right, so you can see that is anything important here. The next question is, where could we enter this syntax, right? Or where can we inject this payload? All right, so this malicious payload can essentially be injected into any application input that's being logged. So we're talking about login forms, password forms, or just any data entry point like an API endpoint, HTTP headers as specified right over here, right? So in the case of Apache Solr, there is an API endpoint that's being logged under Solr admin core, so just admin cores, right? And now that you have a better understanding of how Log4j works, you should understand that this is where you supply your inject syntax. You can simply supply HTTP GET variables or parameters, which will then be processed and passed by Log4j. All it takes really is the single line of text, and that is what makes this vulnerability extremely easy to exploit. So this is the proof of concept, right? So in order to verify that Log4j is indeed running on the target, even though we already know that it is, we need to test and see whether it'll actually connect to our LDAP referral server. But we'll not set up the referral server just yet. What we want to do is set up a netcat listener that will receive the LDAP request. So I'll say netcat NVLP1234, and we'll listen on that particular port. I'll then open up a new tab here. And what we can do, actually, let's just open up a new, I'll just split that terminal there. And let me get my IP address here, ifconfig, and we're looking for the tunnel 0 interface. So I'll just copy that. So what we can do now is make a curl request to the actual target web server and then pass in or inject the malicious payload. So we're looking for Solr admin calls. We'll just copy that syntax there because we already have it set up for us. So there we are. We're connecting to port 8983, Solr admin calls, CMD, JNDI, LDAP, and then we specify our IP address here, right? Because we're going to be connecting to our netcat listener, and we say we want to connect to port 1234, right? And we then hit enter. And you can see that we get a connection on our netcat listener, which means that indeed we were able to actually, get Log4j to connect to the LDAP server. And in this case, because we haven't set up an LDAP referral server yet, we only set up a netcat listener. It will connect to the netcat listener, and of course we don't get any useful output, primarily because this is an LDAP request. So I'll just terminate that there. And if we go back into the Try Hack Me page here, we can see we've already done that. We've set up the netcat listener, and we also again ran the following request with curl, right? So we'll hit complete, and you can see verify you've received the connection by seeing the following message, which we have complete. All right, so let's move on to exploitation. Okay, so proof of concept is done. Exploitation. All right, so at this point you've verified that the target is in fact vulnerable by seeing the connection caught in your netcat listener. However, it made an LDAP request, so your netcat listener may have seen was non-printable characters, strange looking bytes. We can now build upon this foundation to respond with a real LDAP handler. We will utilize an open source and public utility to stage an LDAP referral server. This will be used to essentially redirect the initial request of the victim to another location where you can host a secondary payload that will ultimately run the code on the target. So we need to set up the actual LDAP referral server. We can then inject the malicious payload, into any endpoint or any input, application input, right? And once we do that, it'll reach out to the LDAP referral server. The LDAP referral server will springboard the request to a secondary address, which is going to be a web server that we will set up to host the malicious Java exploit, and it's going to be a class file. The victim retrieves and executes the code present in the address that we specify, and that, as it says here, that means we'll need an HTTP server which could simply host any one of the following options, right? So we can use any one of the following options, so it's fairly simple to understand there. The first order of business, however, is obtaining the LDAP referral server. We will use the MarshalSec utility, so let's open that up in a new tab here. And this particular utility allows you to set up or to stage an LDAP referral server for the purpose of JNDI lookups with Log4j. So all you need to do to utilize this or to get this started, to actually utilize this particular utility, is clone the repository, which I already have done. And you can see ultimately this needs to run Java. Reviewing the README for this utility, it suggests using Java 8. You may or may not have success using a different version, but to play by the rules, you'll need to match the same version of Java used on the target virtual machine. So just keep that in mind, right? So I've already completed that. I already have Java 8 installed. You can also just expand this particular drop down here to go through the process of installing Java 8 or OpenJDK 8, which is highlighted here. And yeah, so I've already done that, so I can skip through that. And then next, you'll need to retrieve the marshal-sec utility referenced previously, which we've done. Steps to download marshal-sec locally, we've completed that. And then we must build marshal-sec with the Java builder Maven. If you do not yet have Maven on the system, you can install it through your package manager. So sudo apt install Maven. You then need to run the following command, Maven clean package dskip tests, right? So I've already done that, and you can see with the marshal-sec utility built, we can start an LDAP referral server to direct connections to our secondary HTTP server, which we will prepare, right? So in order to do this, what we are going to do is I am just going to open up my terminal here, and let me just close this up because we don't need it right now. You can see that under the following directory, I have the marshal-sec directory, and under that, I have the target directory where I have compiled it right over here. So you can see marshal-sec 0.03 snapshot all jar, right? So I already have that compiled, which is great. And I can just take a step back. And what we need to do now is say sudo cp to execute the jar file. Sudo java cp, and then we specify on the target we want marshal-sec 0.3 snapshot all.jar, and we then need to specify the actual LDAP server domain, which is marshal-sec.jndi .ldap referral server. So I'll just copy that there. Make sure that this is correctly set up. You can always customize the actual domain by modifying the source code and then compiling it. And then we need to specify the address of the web server that will be hosting the malicious Java exploit class, which in this case is going to be hosted on our IP address. So ifconfig, let me make sure that I'm getting that correct here because I don't want to repeat this process again. There we are, and we'll host our web server on port 8080, right? And the actual name of the resource that we're looking for or that we want to download is just going to be called exploit. And it'll automatically download or instantiate the class file, so we don't need to specify the extension there. And if we take a look at the syntax here, it looks like we have everything ready to go. So I'll just hit enter, paste in my password, and you can see it tells us listening on our IP address on port 1389. So the LDAP referral server is set up, which is great. We can now set up our Java exploit, right? So I'll just go into a new terminal, and I already have created a simple Java exploit payload. So if I cut the contents of exploit.java, you can see that it's essentially a reverse shell exploit whereby it executes a netcat and then connects back to our listener. So we need to modify the actual attacker IP. So I'm going to do that right now. So vim exploit.java, and again, hopefully I've not forgotten my own IP address, although I think I have done. I probably need to save it somewhere that I can access really quickly. We're looking for tunnel 0, and we'll leave that open. So I'm just going to replace this here. So the attacker IP, and of course you can change the port you want to connect back to. In this case, I will just paste that in there. We're connecting back to 9999, which is fine. Write and quit. And then we need to compile this Java code into a Java class, which can be done using the Java compile option. And then we say, the actual source. Before we do that, let's specify the exploit.java file. The source is written in Java 8 or is compatible with OpenJDK 8. And then the target is going to be executed on OpenJDK 8. You can change this based on what version of Java is running on the target. In this case, I'll hit enter. If I list out the contents now, we have the exploit.class file, which is what is going to be executed on the target system. Now, we need to host this. So again, we need to set up the Python. We need to set up the web server that will do this, and we'll utilize the Python module simple HTTP server. And remember, we're hosting this on port 8080 as we specified in the arguments when setting up the actual LDAP referral server. So 8080, make sure that that is correct there. I'll hit enter. And it's going to host these files on port 8080. We now need to set up our netcat listener on port 9999. So netcat nvlp 9999. That's going to listen for the reverse shell once it's executed. And then we can open up a new tab here and actually make the curl request again. So let me see if I have the curl request at hand here, which I believe I do. There we are. So curl Solr admin cause, we inject the actual malicious payload. So JNDI LDAP, we specify the address, which is our IP address, and then we need to change this to port 1389. That is the port where the LDAP referral server is currently running. And this we want to change to exploit, and we can essentially hit enter. And looks like we have a syntax error here. So curl 1389. Let me just make sure that the syntax is correct there. All right, so it looks like the syntax was correct, and we get a connection from the target. So on our netcat listener, we get the connection. So if I type in ls, you can see we've successfully been able to get access to the target system. And then, of course, I can import, or I can spawn a bash session by saying Python C import pty.spawn, and we can then spawn, bin bash. So bin bash. And we can then hit enter, and we should get a bash session. There we are. So we have currently gained access to the target server, and that's really how simple it is in regards to exploiting a target that is running Apache Log4j. So we can then perform our basic enumeration, like who am I? We're currently logged in as the user Solr cat etc release. You can see that our current, this will display our current distribution version or distribution release version. So this is running on Ubuntu 18.04.3 LTS. Let's take a look at the try hack me documentation here. So we've done that. We've set up, no, there we are. Let's take a look at this here. So what's the output? Just the IP. That is for the LDAP referral server. So the output we got was listening on the following address 1389. So let's paste that in there. All right, that's correct. We set up the exploit code. We also compiled it. We set up the web server. We set up the netcat listener. We made the curl request. And there we are. So we've essentially established our initial foothold on the target system, right? And it says at this point, a threat actor can realistically do whatever they would like to do with the victim, whether it be privilege escalation, exfiltration, install persistence, perform lateral movement, or any other post-exploitation. So potentially dropping cryptocurrency miners, which we have seen, remote access trojans, stages, beacons, implants, etc. Right? So please hug any incident responders that you know. I definitely did over the weekend. And then, yeah, so after receiving a reverse shell, feel free to experiment with any other commands you could run with your exploit or Java payload. So we can get a interpreter session fairly easily. And the way we can do that is, let me just go back in here. And on our netcat listener, well, actually, before we do that, you can actually see on the LDAP referral server, once it gets the request, it'll actually redirect it to our web server. And it correctly identifies the file and the extension exploit.class. And on our web server, you can see that we get a GET request, and that has the status code 200, which means it was successfully downloaded, and then it is executed on the target, which gave us the reverse shell. So let me just terminate this reverse shell, and what I'm going to do is I'm going to set up a Metasploit or MSF console resource script. So vim handler.rc, and within this, I'm going to say use multi-handler. And we're going to set the lhost to our IP address. So again, ifconfig. There we go. I should have kept that on hand. So lhost, and then set the L port to port 9999. So this has to reflect the port that you set when setting up the malicious Java exploit. And then we hit run. And this will essentially just automate our entire process here. So let me just get rid of that line there. So write and quit. And then I can say MSF console resource script handler.rc. So handler.rc, hit enter. That's going to set up the reverse TCP handler for us. And we can then use the curl or make a request with curl to get the command shell session, which we can then upgrade to a interpreter session. So we'll give this a few seconds to start up Metasploit or the Metasploit framework console. There we are. All right, as we can see, it sets up the reverse TCP handler. And of course, the payload, the default payload is always going to be generic shell reverse TCP. And then we can make our request with curl. So I can say curl, hit enter. And right over here, we should get a connection. I'm just going to wait for it. All right, so as you can see, we get command shell session 1 open. So I can say ls, the same thing. So I'll put this in the background. And if I list out my sessions, you can see we have session 1, and that's a standard command shell session. So I'll say sessions upgrade 1. That's going to give us a meterpreter session. There we are. It actually starts the reverse TCP handler on a different port, which is great. It sends the stage, and let's see whether we get a second meterpreter session. There we are. Meterpreter session 2 opened. It stops the exploit multi-handler. And if we list out our sessions, we have meterpreter now. So sessions 2, and there we go. So sysinfo, and you can see it's running Ubuntu 18.04 and the kernel is 4.15.0, so on and so forth, right? So fairly simple. Let's take a look at the next tasks here. So these are really pertinent to persistence. So now that you've gained a reverse shell connection on the victim machine, you can continue taking any action you like to better understand this vulnerability. Let's grant ourselves better access, right? Analyze the affected logs and even mitigate the vulnerability. You may have noticed that you earlier nmap scan, within the nmap scan, we noticed that port 22 was open. We did not know any other usernames or passwords at this point, so trying against that protocol would be useless. But now you have code execution as a user. You could potentially add private keys or change passwords. So who am I? We know that we are Solr, that we already did, right? And it says if you'd like to stabilize your shell for faster ability in typing commands, we've already set up a meterpreter session. Now that you have a stable shell, you can safely use the left and right arrow keys to move around your input. We pretty much have that already to a certain degree. We can check the super user permissions. So we can get a bash session. So I'm just going to say shell, and we can then use Python here. So we'll give that a couple of seconds. There we are. Type in ls. Looks like it's working. So Python, and then we can say Python C, and then we say import pty pty.spawn, and we can say we want a bash session, so bin bash, hit enter. All right, so now that that is done, what we can do is, let me navigate to the to my home directory. We can essentially say sudo l to list out, the actual permissions, and you can see user Solr may run the following commands on Solr. So we can pretty much run all sudo commands without providing a password. And if we list out or take a look at this here, we can see sudo l, check your super user permissions. We've done that. If you'd like to grant yourself persistence and access into this machine via SSH, momentarily become root and change the password for the Solr user to one of your choosing. This way you can SSH in as needed. So we can essentially change the password of the user Solr. So I can say sudo password Solr. Right, and we can say password 123, password 123, right, and that is going to be updated successfully. I'll just copy the target IP now, and then we can log in and via SSH. So I can say SSH Solr at the IP here. We'll say yes, we want to accept, and we'll say password 123, and we should be able to log in via SSH and have successfully established persistence. So there we are. We currently have access as the user Solr, and we can pretty much run all sudo commands without providing a password, which is great. And then we can hit complete there, and that is done. All right. So for detection, right? So I had a 9E live session with Jason Alvarado on Friday, where he essentially covered the various techniques you can use to detect this particular exploit. And just going through the documentation here, you can see it says, unfortunately, finding applications vulnerable to this vulnerability or the Log4Shell attack is hard. Detecting exploitation might even be harder, considering the unlimited amount of potential bypasses. With that said, the information security community has been has seen an incredible outpouring of support and effort, to develop tooling, scripts, and code to better constrain this threat. While this room won't showcase every technique in detail, you can again find an enormous amount of resources online. So you can take a look at how to create Yara rules. You can take a look at the various jar and class hashes based on the malicious Java classes that are being used. And of course, these can be very helpful in identifying signatures or creating signatures, right? So to explore our own logs, use your SSH connection or reverse shell to move into a directory where the Solr logs are stored. You already know what the path is. We know that path, so I'll navigate into that there. Review the log file that you know is affected by the log4j vulnerability, so we can actually do that. So if we say cat var Solr logs, and that is solr.log, I'll be able to show you that this, our actual injection, or the actual payload that we injected in order to gain access, was logged, right? So if I cat out the contents there, we'll give this, let's see if I can identify it here, where, there we are. So you can see right over here that the path admin calls, that's the API endpoint, and then the parameters specified, you can see that we have the JNDI LDAP payload, and it connected to the LDAP referral server, and that's essentially been logged. So that's one way of detecting this, is by taking a look at the logs. So notice that your JNDI syntax, attack syntax included in the log entries, yes. So that is done. Okay, so bypasses. So I'll be making another video covering the various bypasses, or bypass techniques you can perform in the form of obfuscation. So the JNDI payload that we've just showcased is the standard and typical syntax for performing this attack. If you're a penetration tester or red teamer, this syntax might be caught by a web application firewall or easily detected, as companies are already doing or adding rules to detect this particular payload in requests. If you're a blue team or incident responder, you should be actively hunting for and detecting that syntax. Because this attack leverages Log4j, the payload can ultimately access all of the same expansion, substitution, and templating tricks that the package makes available. This means that a threat actor could use any sort of tricks to hide, mask, or obfuscate the payload. And these are the various resources online, as as highlighted here, that these are essentially the various bypass techniques that you can use. And of course, they utilize templating, substitution, obfuscation, etc. So again, for example, you can see here that in this case, what's happening is let me just use this example here. You can see that the actual characters, so JNDI is being split, and they're using various JNDI parameters to specify lowercase j, NDI, lowercase l, lower d, p, etc. So these are your typical obfuscation techniques, right? And then it says, note the use of the RMI protocol, which again I'm aware of. You don't need to you don't really need to use LDAP or an LDAP referral server. You can also utilize RMI to load an external resource. So this is also another valid technique that can be used with the MarshalSec utility. So we'll actually be taking a look at how to do that, right? Additionally, within the Log4j engine, you can expand arbitrary environment variables if this wasn't already bad enough. Consider the damage that could be done with remote code execution, but a simple LDAP connection and exfiltration of an AWS secret key, right? So you can essentially extract environment variables, or the values of environment variables, and important ones like, an AWS secret key, which is super, super, super bad. All right, so I'll just hit complete there. As for mitigation, we can actually go through the process of mitigating this. So now that you've acted as the adversary for a little bit, please take off your hacker hat and let's mitigate the vulnerability on this vulnerable machine. Review the mitigation techniques suggested on Apache Solr's website. So for every application that's affected by this vulnerability, they're going to have instructions as to how you can patch that vulnerability, and most of them have either disabled the JNDI lookup plugin, or in this case, in the case of Apache Solr, what they've done is they've recommended essentially enabling the following options. So Solr options for dlog4j. So for log4j, the format message no lookups is set to true. So we can perform external lookups, with JNDI. So that's really the way we can essentially patch this. So we can locate the solr.in.sh file, which again, what am I doing there? So we can essentially locate it, and we need to have root access to modify it. So I'm just going to copy this here. And what is the full path of the solr.in.sh file? So we actually need to find it. I'm just going to go back into my Meterpreter session here. And we can use the find utility, we can use the search utility and say the file is solr.in.sh, right? And There we are. So that's the actual path there. So we'll copy that and paste this in here. That's where we can find it. We then need to modify it, and we then need to add the following option. So again, you require root access, and we can use a text editor like Vim. So I'm just going to use my SSH session here. So I'll say Vim, and we'll paste in the actual path to that file there. And we need to add that configuration option or this particular syntax to the end of the file. So we'll head over to the bottom here, and we'll just insert that or paste that in there. And we can write in quit. We then need to restart the Apache Solr service. So we'll just hit complete there. So sudo etc init, so that's the init system there, and Solr restart. So fairly simple. We're going to restart it, and then we'll try and run the exploit again just to show you that it doesn't work, or the lookup or the GNDI lookup will be disabled, which means we will not be able to connect to the LDAP referral server. So we'll give this a couple of seconds. There we are. It's restarted it. So we'll hit complete there. So we'll just go through the process of replicating the attack again. So what I'll do is, let me see, we have the LDAP referral server there, which is currently active. We then have the web server that's hosting the exploit.class file, and we can just hit exit, right? And what we can do, sessions, this is currently on port 999. Yeah, let's just kill all the sessions here just to show you that this will not work. So I'll say we are currently using the multi-handler, so I'll say run, right? And that's going to start the reverse TCP handler. And let me verify that Apache Solr is currently running. So I'll just open this up in a new tab there, and that is 8983. Is that the correct? Looks like it's working. All right, so I just restarted the Solr service again. For some reason, it wasn't working then. We've been able to mitigate it by adding the configuration. So if we go back to our listener here, we can make a new curl request. So I'll open up a new tab here, and we'll just say curl. And yeah, that's essentially everything is specified correctly there. GNDI, LDAP, we have the LDAP referral server port, and I hit enter. And if we take a look at the actual handler, or rather the actual LDAP referral server, you can see we don't get an LDAP request, which means it'll not actually forward or redirect it to our web server that's hosting the exploit.class file. So we've been able to successfully mitigate this vulnerability. So that was fairly simple, right? So that is done. And that is also done. And yeah, so that's mitigated. Fantastic. So patching. So let's take a look at patching. At the time of creating this exercise, Apache Solr 8.11.1 has not yet been released to the formal patch for CVE or the Log4Shell attack. Alongside many other software providers, the industry is frantically scrambling to patch this software and push it downstream to users as quickly as they can. All right, so please be understanding of this frenzy. There's so many potential places that this Log4j vulnerability could be present. We may never see the end of this vulnerability for a long time. The onus is on you, on me, on each and every one of us to raise awareness of this incident and hold the community accountable for actively responding. When the time comes, roll out the patches that have been made available and continue to hunt for instances of this vulnerability. All right, so again, that's something that I also recommend, for any Java-based applications, regardless of whether they're web applications or just standalone Java-based applications like Minecraft. Try and see whether they're utilizing the Log4j package and try and see whether they are vulnerable. Submit a disclosure report so that the company can get it patched. As I said, we're still learning more about this vulnerability and how many systems are affected by it. So it's going to take a while. As I said, make sure that you perform your research. As I said, I'll also be covering or making videos on other products that are affected by this vulnerability and how they can be exploited and the various ways they can be patched or mitigated, because that's very important. And I don't want this just to be focused on exploitation. All right, so I understand the implications of this, and I will patch early, often, and always. Indeed, we will. And that is pretty much it for this room. So yeah, that is essentially the process of exploiting the Log4j vulnerability, also known as Log4Shell or identified as CVE 2021-44228. I would love to hear what you guys think, any of your personal experiences with this particular vulnerability, any patching tips, anything that you've been able to discover. If you want to reach out to me personally, or bring on or actually continue the discussion, you can join our Discord server. Link is in the description, or you can contact me via Twitter, as I do respond primarily through that platform. That being said, thank you very much for watching. Please like this video and share it to spread awareness, and I will be seeing you in the next video. A huge thank you to all of our Patreons. Your support is greatly appreciated, and this is a formal thank you. So thank you Shamir Douglas, Ryan Carr, Sandor, Michael Busby, Sid Saab, Doozy, Tafim Bari, Dustin Umpress, and Michael Hubbard. Your support is greatly appreciated, and you keep us making even more high quality content for you guys. So thank you.